Chris Chinnock here for Insight Media. It's Display Week 2023. I'm in the MICLEDI micro displays booth. And they have kind of an interesting perspective on this. They believe that the only way that micro LEDs can be cost competitive, and they're really focused on the AR space here, is that you need to have silicon foundries doing these devices. It has to be a silicon-based process in order to get the cost advantages and the yield advantages that silicon foundries can bring. So they looked at the CMOS production workflow, where they are bonding, doing multiple layer bonding of silicon wafers, CMOS sensors, to create those devices, backside illuminated CMOS devices. And they said, well, that looks pretty interesting. Maybe we can adapt that for micro LED production. But the issue is when you take gallium nitride epi layer on a silicon backplane, for example, a silicon carrier, it does not have the planarity that you need to do wafer bonding and silicon processing and all this stuff. So that's a big, big problem. So their solution was to basically fix the planarity problem. And the way they do this is kind of illustrated here. What they do is start by taking known good dye. So they start with a gallium nitride or an AlGaP red wafer level that's already been processed to create the red, green, and blue devices. It gets diced into individual devices. And then what they do is put this onto a bulk silicon wafer. Okay, so here's your 300 millimeter carrier. They call them epi chiplets. So those can be then these are, I think, only 1 millimeter thick or so. And so this is they call it a reconstituted 3.5 wafer. It can now go into a standard silicon foundry with all the planarity that you need to do this. So these can now be processed to create the micro LED devices, and then get bonded to a silicon backplane to create these devices. Of course, now you've got 3 discrete wafers at this point, and so you have to, if you want to make a full color display, you can make it with like the way Jaybird does it, with 3 separate devices and a cube combiner, or use some kind of a quantum dot converter, or as we're starting to see a lot more at this SID, we're seeing single pixel solutions, which might stack epi layers or other ways of creating a single pixel full color solution. So their news is that they're basically demonstrating that this capability exists. They've got test platforms here that they're showing, and they're ready to work with some of their partners to move this forward.